All right, Mr. Benzel here again. And now I'm going to kind of show you your homework exercise today. Now, one thing to kind of keep in mind, if you find me annoying and you would like maybe another perspective, you are always welcome on your Delta Math to actually look at the embedded videos. And there are kind of videos and explanations for each problem, and I kind of give you like a family of problem for you to kind of continue to practice on. So anyways, what we are going to do today is do the limits of table of values. And this is going to give you just kind of a really in-depth understanding of how a limit works. And what we're going to start with is this f of -3. So, there's this function, and we're going to see what happens if I put in -3. So I'm going to try and see what that y value is. So I click try value, and that's 1. So the question is, does the graph behave the same way around 3? So what I always like to do first is I always like to test out the one-sided limits. So I'm going to choose a number. So I'm just going to go with this first limit here. So -3, actually, from the left. So I'm going to choose a number that's a little bit less than -3. So maybe I'll try -3.1. I'm going to try that value, so I get 1.5. Now I'm going to get a little bit closer to -3, so maybe I'll try -3.01. I'm going to try that value, and I get 1.05. Or I could try -3.001. So remember, just to the left of -3. And I'm getting pretty darn close to the number 1. So I feel pretty confident that I will be approaching the number 1. Now let's actually go and try, for instance, -2.9. So this is a little bit greater than -3. So I'm going to choose a number a little bit greater than. And I get 0.79. I'm going to get a little closer. Get 0.9799, and I'm going to get even closer. So I'll try -2.99. And that is 0.997999. So that's essentially the number 1, and it's as close to the number 1 as you can be without being number 1. And this is kind of like the paradoxical notion of what a limit really is. Now notice here, the left-sided limit and the right-sided limit are the same. So if they are both the same, then the two-sided limit, so that's the limit without the plus or the minus symbol, is also going to be 1. And what you can do after that is you can kind of submit your answer here. And da-da, that looks good. Let's try something a little more interesting. Let's just do one more. So I'm going to try, seeing what the y value is at 5, and that tells me that it's undefined. So I'm just going to move the undefined box at f of 5. I'll just click in here, undefined. And then I'm going to try a number a little bit less than 5. So like, let's say 4.9, maybe 4.99 and 4.999. And I get ever so close to what looks like -3. Now I'll just kind of clear my table here so that it's a little bit less busy. Next I'm going to try something a little bit bigger than 5. So maybe 5.1. See what that value is. Try 5.01, 5.001, and that happens to also be -3. So then the two-sided limit since they kind of match the left and the right side, the two-sided limit would be -3. So this is how you do limits from a table of values. And I wanted to kind of just show you, how I would think about it if I was given these Delta Math problems. Please make sure that you're kind of taking notes as we go along with these videos. And also on the notes, I really love it when you submit them and write questions on the side or highlight key material. So this is your time to really try organically to take notes from our discussions on these. And that way I can answer your questions when we get together next class.